So in the next part of our chapter, we're going to compare the different channels of communication, but we are going to group them together. Those that require physical links, such as wire pairs, coaxial cables, and optic fibers, to compare between these three. Why we compare these three? Because all three require physical connection, physical links. Then we'll compare the wireless connections, which is actually your whole radio spectrum lah. Okay, starting from AM way up to satellites and microwaves. Now, what are we going to compare? We're going to compare in terms of bandwidth, that means how much information can be transferred. Noise, as in how noisy or how clean your signals are. Cross-linking is when two or more signals overlap. Security is talking about whether people can steal your information easily or not. Signal attenuation talks about drop in signal power. Repeaters and regeneration, whether you need repeaters or regenerators and how many you need. And then finally, cost and convenience. So the first thing we'll talk about is the wired one, the physical link one, which is a wire pair. So let's talk about wire pair, then we'll talk about coaxial, then we're going to talk about optic fibers. Wire pairs are the most basic form of communication using physical link. Remember this Alexander Graham Bell, who invented the telephone. Now before that also, you have all these people communicating during the World War using Morse codes. All these are using wires. For example, in the Morse code, you have a switch here, a battery, and then your buzzer at the other end. Every time you close, you'll hear either a beep or a buzz lah. So you can transmit Morse codes lah. In a more advanced form of wire pair, which is our telephone line, we will have two wires. One connecting from your speaker out, another one coming from your, outside to your speaker, another one coming from your microphone outside. So what will happen is you use one wire to transmit your voice, one wire for your friend's voice to come to your speaker lah. So they have two wires running parallel to each other lah. If you don't believe, you can cut out your telephone wire. That means if you're still using the copper one, not the optic fiber one, you will notice there'll be two wires inside lah. But what are the advantages and disadvantages of this technology? Now this technology is the oldest one. So it suffers from the greatest attenuation, which is the greatest loss in signal power. Why? When you're talking about alternating voltage, it travels along the wire. It will cause your current to dissipate energy as heat. So that is one source of attenuation. Another thing is, as it goes back and forth, the electrons are accelerated and decelerated, so they will emit EM radiation. So that causes energy loss as well. So because of that, you can only limit your bandwidth. That means the maximum frequency that you can transmit to 500 kilohertz. More than that, your attenuation will be too great. So therefore you can only limit to 500 kilohertz. Now let's talk about the repeaters or regenerators. If you're talking about analog, we use repeaters. Digital, we use regenerators. Now for repeaters, right, because the attenuation is so great, in the end you will need many repeaters in order to transmit large distances. So that can add up to your cost. Even though the cost of wire pairs themselves are not that expensive, but the cost of repeaters may actually will cause the cost to increase. Okay? Talking about convenience is not very convenient, because anything that requires a physical link, you cannot carry around. Right now, can you carry a house phone everywhere you go? So it's not that convenient lah. And what about in terms of security and cross-linking? Now, for this type of communication, like using the telephone line, your security is very low. That means, have you watched spy movies? They will tap people's phone. So one of the ways they tap the phone is they pretend to be telephone repairman, then they climb up to the telephone pole, then they pretend to be fixing the cable, but actually they're just listening. So all they need is a device to just clamp around your wire. Your wire, which is emitting EM radiation, will induce an EMF in that device, which is alternating voltage. So then your alternating voltage, you connect to a speaker, then you can hear the conversation. So that's so easy. You just have to clamp around your wire and you pick up the radiation. So your security is very low. And talking about cross-linking, I wonder whether you have experienced this when you were young. That when you're talking to your phone, talking to your friend, not talking to your phone, talking to your friend through your phone, suddenly you realize there's another there's another conversationing happening by some other people. Okay, some of you have experienced, some of you are not lah. If you have experienced, it's called cross-linking. That means the two signals get overlap. So why does that happen? If the wire from your house to the telephone, let's say the station there, is overlapping with another wire from another person's house, so your EM radiation from your wire will induce an EMF in their wire, so they can hear your conversation. But their EM radiation will also induce an EMF in your wire, so you can also hear the conversation. So that's called cross-linking. And cross-linking, there's nothing much you can do because it's not shielded. So you basically get all this. Alright, so in terms of technology, this is the earliest form of technology. So it's also considered one of the least secure, the least efficient way of doing things. So that's why we're going to talk about a better way of doing it now. We'll look at coaxial cables. So coaxial cables are an improvement of your wire pairs. Instead of just having a wire side by side, like in your telephone wire, so we don't do this. We will make the two wires different arrangement. You will have your inner conductor inside your outer conductor. So your outer conductor will surround it, but of course it's separated by an insulator in between. Your inner conductor is actually a copper wire, which is actually quite thick, thicker than your normal telephone wire. But the outer conductor is a bit different. It's actually copper braiding. What is copper braiding? Imagine you remember how girls used to like tie their hair, and then they will like take two strands of hair, then they keep on intertwine them. Okay, or three. Okay, 3 or 4 or 5 whatever Okay. So you will actually intertwine them. It's called braiding. So instead of using a solid copper cylinder to enclose it, they will just use braiding to enclose it. So why they use braiding? They use braiding because your braiding are made of thin strands which they can actually wind around right now, so that this cable is more flexible. If you use a solid but hollow copper cylinder, let's say a hollow copper cylinder, and cover this, you won't be able to bend it easily. That's the reason. But because of the braiding, it actually doesn't give you 100% shielding. Because why they put the outer conductor here is because the outer conductor is earthed. Okay, it's earthed. So that gives you better security, that reduces your attenuation, that reduces your cross-linking. Why? Because any outside EM radiation, whether it's a form of noise or other people's signal, will pass through your outer conductor first, and the EMF induced will be channeled to the earth. So it doesn't go into your inner conductor. So your inner conductor carries the signal, your outer conductor protects it. So similarly, if let's say you want to reduce attenuation, because your outer conductor acts as a return path, so it goes inner conductor, goes outer conductor goes to inner conductor right now. So the inner conductor is designed to radiate out the EM radiation. The outer conductor is designed to radiate inwards the EM radiation. So therefore they will cancel out each other because they are waves, so they won't escape. So that way, you will not have people, it will be difficult for people to steal your signal because your EM radiation is not supposed to escape. But again, I told you it's not 100% shielding, because copper braiding means that there will be small gaps. So it will be a bit leaking in, a bit leaking out. Of course, the best is to use a hollow cylinder to enclose it, but then it won't be flexible anymore. That's why they have to compromise. So you have better security, because now people find it hard to steal your signal because very little actually escapes. That also means you have less attenuation because you have less EM radiation escaping. So your bandwidth can go up to 50 megahertz, alright, which is higher. That means you can carry a higher frequency signal. In terms of cost, this cost is of course more expensive, but if you transmit over large distances and it saves you on the cost of repeaters, then you may actually make sense to use this. But also because it allows a greater bandwidth, so anything that requires a greater bandwidth will use coaxial cable. For example, if you watch Astro, right, the satellite, right, channels, the cable that connects your dish to your decoder is made of coaxial cable. If you don't believe, you see it's a white color wire, right? You cut it. When you cut it, you will see this inner conductor, a white color or transparent plastic insulator, and then you see copper braiding. But no worries, if you cut it, it's easy to join back only. Okay, once you cut it, you remove it from the head, right? The head, because the head will be this one, you have to insert into a hole, then you screw it here, and then this one you just wind around it only. So you can do it the same way. Okay, if it actually gets broken, this cable, because you bend it too much, you can cut it and do again. Alright, it's actually very simple. Okay, so this is your coaxial cable. In summary, it is just everything better than the wire pair. But always remember, wired connections are never convenient because you cannot carry around. Okay? Right, the next one we're going to talk about is optic fibers. So the optic fibers is our latest technology. Now, optic fibers do not use electricity to transmit information, unlike your coaxial cable and wire pairs. What they use is pulses of either light or infrared. So you can use either light or infrared, but you need to know which one they prefer. Which is better actually, light or infrared? Infrared. Why? Because infrared has a smaller frequency. And EM radiation, right, tends to have greater attenuation when the frequency is higher. So when you have a lower frequency, like infrared lower than visible light, you tend to have less attenuation. Alright, so now let me tell you the technology behind this. Now, an optic fiber is a very thin piece of glass. And how thin is it, right? If you remember, if you eat mee hoon, that is how thin it is. So each glass fiber, right, is as thin as that. So why do they make the optic fibers so thin? There are a few reasons. The obvious reason is so that it's a bit more flexible. Because anything that's very thick cannot bend glass. But it's a very, very thin, you can bend a little bit, but be careful, glass will break. But the more important reason why they will use thin fibers is because of how they transmit your light. Now, if you remember, if your optic fiber has a bend in it, right, how is your light going to travel in a bend? Because normally, light can only travel in a straight line, right? So what they will rely on is total internal reflection. What it means is, actually, if this is your glass fiber, there's a cladding around it. That means there's another, like a medium around it. So you can imagine there's a cladding around here. That is a different medium. So when the light enters the boundary between two media, that means when it enters this boundary between this glass and the top one, it will be refracted. Now, if you remember in your optics in Form 5, if the angle of incidence is bigger than your critical angle, it will undergo total internal reflection. So they're relying on total internal reflection for the light or the infrared to keep reflecting along the cable. So even if your cable is bent, they will actually be able to travel as far as you want by reflecting. But that also means that if you have a beam, now a beam of light or a beam of infrared consists of many rays. Rays as in the individual lines. So here they drew for you two lines which represent two different rays. Actually, it all comes in all at different angles. So when it enters here, this red one, you notice that the reflections and the blue reflections are not the same. So their path lengths won't be the same as well. That means one of them will have to travel a bit further, one will travel a bit shorter distance. So while they may come in together at the same time, they will not exit at the same time. The one that travels further will find themselves a bit longer to come out. So what would happen is, your pulse, you may turn on this light source for maybe half a microsecond. Then you switch it off. Then as the light travels through here and undergoes different path length, different rays have different path lengths, they will come out at different times, so your pulse will occupy a longer time when it comes out, maybe 3 microseconds. So that would mean that you will not be able to transmit as many pulses in 1 second because each pulse lasts longer now. So in order to reduce this problem that it spreads out after coming out different reflection, they make the core as thin as possible. So even though they have different amount of reflections, but the extra distance they travel is not so great, so the path difference will be shorter between them. Means the path difference between the rays will be not so different, and so what will happen is you won't have such a great delay upon coming out of the optic fiber. Do you understand? So that's the reason, the main reason why they make the optic fiber as thin as possible. So what is the advantage of these optic fibers? Now, if you are transmitting your light, you just have to turn on and off to represent 1 and 0. On is 1, 0 is off. So the light will travel, so at the end there you just detect, got light is 1, no light is 0. Theoretically, you can provide a high frequency of 10 to the power 8 megahertz. That means in every second, they can afford to have 10 to the power of 8 million pulses. That's how much you can transmit in 1 second. But why? Because each pulse only needs to last for 10 to the power negative 14 seconds to detect. This amount of short time the pulse it can detect. But of course, logically, because of this path difference, you will never be so high one. Okay? Now, but I remember reading recently as well, the fastest you can actually reach right now is you can download the entire HD movie in few seconds. You just click download and the whole HD movie is downloaded. Yeah, that's the fastest we have achieved using optic fibers. Okay, so that's how fast. But the bandwidth here is a little bit different from the bandwidth in your coaxial cable and your wire pairs. The bandwidth in your wire pairs and your coaxial cable talks about the maximum frequency of the AC. Whereas here the bandwidth is talking about the data transfer rate, like how many megabits per second. The one that you are using for your Unify or your Maxis fiber, they tell you 5 Mbps, 10 Mbps. That is the bandwidth you're talking about. It's a slightly different meaning. So they have a very wide bandwidth, definitely. So it gives rise to large transmission capacity. That's why once they switch over to optic fiber, your speeds of internet shot up. Last time, remember the highest was about 1 Mbps. Alright, for home users. Now you can go up to 20, 30, 50 also got. And in Singapore, it goes to 100 over or 200 as well, with less cost and hours lah. Okay. Anyway, and because of this so wide bandwidth, many people can actually share now. So you reduce the cost by dividing by the number of users. Because the bandwidth is higher, you can afford to have many people sharing the same infrastructure. So that reduces the cost for us as well. But in Malaysia, it's different. The cost never goes down, no. But I won't mention why. So signal power losses in optic fibers are relatively small. So there will be attenuation, but not as great as your wire pairs and your coaxial cable. Why? Because your attenuation is not in the form of heat anymore. So when the current goes back and forth, in your wire pair and coaxial cable, there's energy loss as heat. But this is just the light or your infrared traveling. So there is no power loss as heat because there's no current there. The only source of attenuation is due to impurities in your glass that blocks off a bit of your light. So your attenuation is very low, so you need relatively very few regenerators because digital signals use regenerators. So that reduces the cost for you. In addition, glass is actually cheaper than metal. So if you're talking about new housing area, it is cheaper to set up optic fiber than wired connection using wires because glass is cheaper than metal. Now, diameter and the weight of optic fibers is less than metal cables, so it's easier to handle and store, so that also reduces the cost. They have very high security. You know why? How are they going to catch steal your information when you don't emit EM radiation? Yours is just light bouncing off the inside of the optic fiber. There's no EM radiation generated, so they cannot steal your signal. So it's very secure. That also means there is very negligible cross-linking, because now your signal won't come out, and also if there's any EM radiation that comes in, it doesn't affect you because it will induce an EMF, but you are transmitting light. So it's nothing to do with you. So there will be less noise, less cross-linking. So that means you can actually install it alongside electromagnetically noisy environments. For example, if you already have wires that carry electricity and they use some poles, electric poles to carry it, you don't have to make your own poles, you just hang your wires or coaxial cables next to it, no problem. You make use of their poles because it won't affect you. Understand or not? Okay, and of course optic fibers are ideal for digital transmissions because it's ones and zeros.